Okay, this is part 2 of the Chapter 11 on environment. This will be the last lecture in the International Relations class. Just a reminder here that there's other things that we might have to deal with in addition to our biosphere and our environmental issues. However, speaking of French fries, lack of biodiversity is part of what contributed to the Great Potato Famine, when farmers were very dependent on just a couple of different species of high yield type of potatoes, and that contributed when the blight hit, that wiped those two species out. Biodiversity still matters in this respect, in that if particularly when the French fry industry exploded, there was a particular type of potato, the russet potato, that was very profitable for potato farmers to grow, so that is squeezed out some of the other types of potatoes. So that's just an example of how it works. There's many species in the world that are already extinct. There's probably lots of species that have gone extinct that we never even knew that they existed. And due to the complexity of the world, it's difficult to predict the consequences of loss of diversity. We, as humans, we're trying to survive and produce, make profit in our economic systems and consume and things like that. And we don't really know what the consequences are until after we do something. Part of the sustainable development is trying to get a reasonable idea of that, hold on that. Some of the things that have been done over the years: established a quota on whales to prevent them from going extinct, the dolphins, safe tuna fishing, where particularly low-income farmers could not necessarily afford that. They would throw in the nets and they would grab whatever tuna they could, and there might be some dolphins in there, so that would require a little bit of assistance to try to, as well as monitoring and requirements in order to minimize that sort of thing. But biodiversity is an important factor of our sustainability. This is just a trivia question that I throw out. What is the world's deadliest animal? If you want to take a pause here for just a second and make a guess at it. But going ahead, it's the mosquito. The mosquito is the deadliest animal on the planet, and the human second place there. This is just a compilation of things looking at some different animals out there. Shark only attributed to 6 in this particular time span. Looking at wilderness areas, and this includes rainforest, but shows how much wilderness areas have been lost just since 1993. Speaking of rainforests, about half of the world's species live in the rainforests, and most are in poor states. And if they are trying to develop, then there might not be very much political will to prevent them from being cut down. Even in Brazil, for example, the most recent president was somewhat of an anti-global warming politician. Could have some potential consequences because of that, but deforestation contributes to several things. Contributes to global warming because the forests are soaking up CO2 as well as emitting oxygen. With all the species that live in these rainforests, there's going to be a loss of biodiversity. When you clear vegetation, that leaves the topsoil exposed and vulnerable to erosion. And when you have less vegetation in topsoil, that increases the amount of runoff, because vegetation helps to slow down runoff, and that increases the risks of floods down the way. So there's lots of consequences to deforestation. Here's where the tropical rainforests are around the world. In the tropics, as you would expect there. Reforestation. 7 Latin American states did agree to reforest about 20 million hectares by 2020. That was a UN summit meeting. And as the forests grow, they were expected to remove 1 billion tons of CO2 from the atmosphere every year. Every little bit would probably help as far as reforestation goes. Let's look at the oceans, one of our biggest, or perhaps the biggest, global commons on Earth. 70% of the Earth's surface is the ocean, and over the past several decades, we've been seeing lots of things of concern: overfishing, dumping. We've got a plastic island about the size of Texas that's floating out in the Pacific. the ocean does not belong to any state. According to the UN Law of the Sea, there is a 12-mile shipping lane that technically belongs to the state, and then there is a 200-mile exclusive economic zone where that state has the rights to get the resources from the ocean in that 200-mile exclusive zone. And we've already seen some maps where China is violating those in the South China Sea, trying to get control of some things there. As far as fresh water goes, which is what we have to drink, well, this gives you kind of an idea of how precious it actually is on a global basis, because 97% of the world's water is salt water, which we can't drink. Not good for you. 2% of the world's water is frozen in ice caps, which we can't get to unless we come up with some really interesting innovation that would drill ice cap ice and then ship it to drink, which would be very, very difficult to do. And with global warming, that water that's frozen in those ice caps melts and then goes into the ocean and becomes salt water. So that leaves about 1% of the entire world's water is available for drinking, a la fresh water. But we're not finished yet. 70% of that is used for agriculture, much of that in irrigation, much of that runs off into rivers and then goes into the ocean. So just conservation alone would save a lot of fresh water. It would be astounding how much fresh water you could save just through conservation efforts. 20% of that is used for industry. When you look at how much water it takes to make one hamburger, you can get an idea of how much water is used in the industrial process. So that leaves 10% of that 1% for domestic use, which we use in our households, which we flush a lot of it down the toilets and we let a lot of it run down the kitchen sink. That gives you an idea of a perspective there. By 2050, there are some projections, and global warming could change this somewhat, but as many as 7 billion people in 60 countries could face freshwater shortages. So those could be some serious concerns when you consider that the estimated population is going to be about 9 billion people at that time. So that's a pretty large majority of people that could be affected in some way with freshwater shortages. Here's just another graphic that shows you there's the 3% of the entire fresh water, and then you break that down, and then quite a bit of that is in groundwater, so we'll look at that here in a second. Looking at the surface water, fairly small percentage, and when you break that down, most of that is in lakes, fairly small percent in rivers. Aquifers, these are the underground porous soil layers where fresh water is stored, and we tap into that. Those are typically replenished by rainfall, so when you have a drought, the aquifers will deplete over time. There have been some serious droughts in the United States where aquifers have been seriously depleted, and then you'd have a monsoon rain season, and then it replenishes the aquifers back up. But it's still fairly unpredictable as we go. Researchers have studied changes in the amounts of water in 37 major aquifers around the world in that 10-year period. Of those, 21 aquifers have declined. Now, since 2013, some of those have been replenished, but what they're looking at is the overall averages of decreases versus increases. 13 of those aquifers were classified as being highly stressed, extremely stressed, or overstressed. Here's a map that, if I updated it a little bit, we would probably see that some of these aquifers here have been replenished somewhat, but those are the major aquifers around the world, and as you can see, quite a few of them are getting in the stressed range there. As far as U.S. foreign policy on the environment, let's talk about that for a little bit. United States has generally been very unilateral on environmental policy. We'll look at some examples, but the United States typically tries to avoid these large-scale multilateral treaties so that they don't get hamstrung into doing something that the United States may not want to do, that poor countries may be required to do, but the United States will say, well, we're already doing that, so there's no need for us to commit to some sort of treaty. Backing up into the 1987 Montreal Protocol, this was an interesting example. This was looking at ozone depletion because due to hydrofluorocarbons, particularly aerosol cans, we started to see measurable ozone depletion. And ozone is very important to filter out harmful UV rays, and for somebody like me with red hair, I need that vitally. So the scientists were in agreement, and the politicians, big shock here, the politicians actually listened to the scientists and said that, okay, well, it looks like we need to do something about this. And of course, it was easier to measure than global warming, so I am being a little bit sarcastic there. So what they did is come together, and it was a universal agreement to ban chlorofluorocarbons. And we'll look at the results of that here in a minute, but it is considered one of the most successful examples of international cooperation, where all the states got together, they looked at the science, they agreed that something needed to be done, and they came up with a fairly quick result in order to try to repair this damage and to prevent any more damage. Some of the other major treaties is the 92 Rio Treaty on Biodiversity. I've already talked about the 94 UN Law of the Sea Treaty, which tries to give the states a little bit more guidance on how to use the oceans. The 97, the big first major global warming treaty. And to date, only the Montreal Protocol has been approved by the U.S. Congress. The Congress did not approve the Kyoto Global Warming Treaty, and the Paris Accords were not even submitted to Congress because President Obama knew that they would not approve that, and it was treated more like an executive agreement. And because of that, since the Senate did not approve that and it didn't become law, well, the next president could just tear that up. So that's one of the disadvantages of the executive agreements. Even though that does give the president some flexibility, it does not give the same level of permanence that a law would that was passed by the Senate that we have to comply with, and the future presidents can't just tear that up. So the example of how the United States typically wants to kind of go it alone on this type of policy here, but looking at the results of the Montreal Protocol, where the ozone holes were forming at the poles, it has reduced 3.9 million square miles since its peak in 2000. So it took a while for this thing to start healing up. And the global ban on chlorofluorocarbons started healing that ozone later. Estimate that it won't return to pre-1980 conditions until about 2070, but it is slowly repairing, which is very, very important. And particularly with people like me, the action is estimated to have reduced 2 million additional skin cancer cases per year by 2030. So fairly significant social costs due to this ozone hole, and quite a bit of benefit achieved by states getting together and doing that. The debate continues over global warming. Going back to the 97 Kyoto Protocol, 150 nations have signed that. The United States and China have not. In 2001 was the first big major study by the UN International Panel on Climate Change, looking at the evidence after a couple of decades of theories, looking at a 2 to 5 centigrade degree increase. It's probably inching up a little bit higher than that. We had tried to make some agreements, such as the Paris Accord was trying to make an agreement that would keep that at around 2 degrees. Might be beyond that threshold to do that, but the melting of the polar ice caps is already being seen, and the sea levels are already showing to rise, and that could actually have fairly soon consequences of people that are living in coastal areas. The political divide really hasn't changed all that dramatically. When people are set in a certain ideology, it's very difficult for them to change their minds. And I may have mentioned before, is that when the economic needs are there, they will typically take priority over the environment. And if the economy is going smoothly and booming along pretty well, then people might kind of slow down and say, all right, well, let's look at what we're doing into the environment, and then you might start seeing some policies there. But then when the the economy tanks or starts to go into recession, then environment will again go to the back seat. Typically, that's kind of how it works. Public opinion, as I said, has not really changed significantly since 1989. It has kind of flip-flopped back and forth, and that is almost a direct correlation with either an improving economy or a declining economy. This is from the IPP report, where it looks at this range of projections as we're going into the 21st century here. There's the 2 to 5 degree centigrade projection over the century. This is looking at some coastal areas, particularly in Florida, and this is a little bit misleading because these units are in meters, and a meter is a little bit more than 3 feet, so that's pretty significant. So when you look at 1 meter, which is about 3 feet rise, well, you're looking at some fairly low-lying extreme areas here where that could happen. That just gives you an idea of 1 meter Mike could do of sea level rise. So global warming has been tied to energy policy because we need the energy, and if fossil fuels contributes to global warming, then that's going to contribute to the debate over whether or not we should be using fossil fuels. So more research and development is in the pike as far as alternatives to fossil fuels, or even perhaps the underground storage of carbon dioxide. How can we capture carbon dioxide and still potentially use the fossil fuels and then prevent those from the CO2 from going into the atmosphere? The battery technology for plug-in hybrid cars has made a lot of strides, but the market is still not there as far as incentivizing the majority of the population to use electric cars or hybrid cars. Biomass, looking at other type of biological energy sources, things like bacteria. Those have made some strides, but still a long way for them to use on a large scale. I already talked about nuclear power, which could be a very viable alternative that could have put a pretty big dent in fossil fuels. However, because of the nuclear accidents that we've had and a couple of near misses as well, the nuclear power is pretty much stagnated over the past few decades, and very difficult, no political will to pursue nuclear power could potentially be in the future if could figure out how to safely store nuclear waste or recycle it or figure that out. So there's lots of scientific challenges out there that could be worked on, and so that's why I'm here. For one, not only did I used to be an engineer, but I'm a big believer in students getting out there, getting smart, sharpen up on your math and science, and get out there and try to figure out how to solve some of these problems. Gasoline tax, according to economists, is probably the most effective way of curtailing driving. If you add $1 to a gallon, introduce it gradually, that would cause people or incentivize people to drive less, use more carpools, use more telecommuting. So got a lot of things going on down the way that could contribute to that. There have been, particularly under the Bush and Obama administrations, there was higher fuel economy standards so that vehicles were required to burn less gas, and those have been backtracked somewhat since the Trump administration. And also, one of the things that has helped to curtail some of our greenhouse gases is more domestic natural gas. Now, natural gas is also a fossil fuel. It just doesn't put out quite as much of the greenhouse gases, so it's somewhat of a trade-off. We've dropped quite a bit in coal, but natural gas has picked up that slack, and so as a result of that trade-off, we have curtailed, or at least up until couple of years ago or so, we have been curtailing our greenhouse gas emissions. Now we're kind of on the upswing at this current time. The fate of the Arctic region, for example, has to be moved out of the world of scientific observation into the world of government policy. So we're looking at global problems here, and they require global political solutions. The Copenhagen Accord in 2009 was a fairly major agreement that the United States agreed with, but of course it was little more than a resolution. And this was where I was talking about earlier, where they were trying to limit it to a 2 degree centigrade increase. And that's very hard to predict. And it would take a massive global effort for that to occur. And the G8, the biggest 8 economies in the world, would have to decrease their greenhouse gas emissions 80% by 2050, which is very unlikely unless there's just an incredible turnaround in policy. So that shows you the challenges that there are out there to combating this greenhouse gas emissions. And another big problem that we've already talked about with international legal institutions is with any type of international agreement, it's very difficult to enforce. And with the Copenhagen Accord, there were really no provisions for monitoring or reporting or even verification. Very hard to follow up on who's doing what they said they were going to do. Somebody could be kind of cheating on the deal a little bit in order to boost their economy, take advantage of a situation in the lag time that it would take to make these transitions. The U.S.-China agreement in November 2014 was a major turning point in a way, where the U.S. agreed to cut carbon emissions 28% by 2025, and those have been pretty much kind of discounted in the current administration. China will peak its emissions by 2030. As far as we know, they are still moving towards that, particularly with their cutback from the use of coal-fired plants. And they were looking at transitioning to 20% of its energy from zero carbon sources by 2025. Because of the current relationships between the two countries, difficult to verify how far we've gone on that, and a lot has happened since that agreement, but at least it was a major landmark in coming together, the two major economic powers that are producing the most of the greenhouse gases. The EU is a little bit more progressive on this because of their more of a collective type of culture. They've agreed to cut greenhouse gas emissions 40% by 2030. There's lots of other things that have been happening in Europe. In the EU, the strength of the EU may have something to do with this as well. And if the EU continues to fight for its survival, this could potentially be at risk as well. This is looking at the projection after these agreements were made. We see that China bypassed the United States quite dramatically there as we get into the second decade. And these are the projections that were promised. These have spiked back up, and China, of course, trying to develop, was going to more slowly curtail. So that's another thing that makes these agreements difficult, because somebody will say, well, why do they get to continue developing with fossil fuels while we are agreeing to cut back? So it is a very complicated political problem, to say the least. So are we inching forward? Another conference in Lima, 190 states come together. But again, according to the difficulties with international agreements, no requirements were made to provide details on how they will achieve these greenhouse gas emissions cuts. So we are seeing some progress even on the local and regional levels. In 2015, a Dutch court actually ordered its government to slash greenhouse gases by 25% from its 1990 levels within the next 5 years. So in the lack of global agreements, there are regional and local agreements that are trying to do what they can, and they could potentially interconnect and build into a larger regional, perhaps even global type of progress. The Paris Agreement, also known as the Paris Accords, in December 2015, 170 states have ratified that. The United States agreed to it, but again, it was not signed as a treaty, more of an executive agreement, which was then torn up by the subsequent administration with the intent of focusing on the economy. So there's where the trade-offs are, and that's where the political differences still are. And even when you look at, particularly in the rich versus poor states, lots of differences. The poor states who would like to develop similar to the way the United States and other Western powers developed, which they did that quite a bit on fossil fuels. And if the poor states are required not to use fossil fuels, then they may require compensation from wealthy states. If we want to get in on the ground up with these sustainable energy sources, well, we're going to need the technology, we're going to need the financing, we're going to need the help. Otherwise, we're going to have to use fossil fuels just like you did in order to develop. So more of the complications here. The debate is over, do we just keep relying on voluntary compliance, or how do we take it to a more aggressive action to where these treaties will actually have some sort of inspectors or monitors or even some sort of penalties or fines that states are going to be agreeable setting up in order to put a little bit more teeth in these types of agreements. And as I've said before, Trump administration did announce withdrawal on that, arguing that it was unfair to U.S. workers. In other words, trying to focus more on a more national-leaning economy. As I was joking earlier, this chapter is, I kind of call this my gloom and doom series as to what's facing us, but I do try to end on a relatively positive note here when you look at the attempts of agreements and other different efforts that are being undertaken to try to at least get a little bit more handle on this. And science, of course, will continue trying to figure out what's ahead, what we're facing, and things like that. So this wraps up Chapter 11. Of course, this is also the final lecture in the International Relations class.